Hello everyone, and welcome to another Waterline tutorial video where we will be talking about water simulation, but this time with a bit more focus on characters. So to start us off, we've just created a blank level in Unreal Engine 5 with just the third-person template. So if we press play, we have the new third-person character from Unreal Engine 5. Some of you may have noticed that in Waterline we actually used the old mannequin from Unreal Engine 4. So let's just see how things are working with a brand new character, brand new project. So this is pretty much blank as you would create level. The only thing that we have done is migrated Waterline here, and under our project settings over here, we have created our additional object channel called Waterline and set it to overlap. So everything will just work pretty much out of the box how we'd expect it to. So let's see what happens when we add in Waterline. So we're just going to add in our ocean, add a little bit more depth to it, and let's hit play. And straight up out of the box, we could see that Waterline works exactly as you would expect with our characters. We're getting our nice interactions, and everything is working pretty great, aside from the colors of the ocean not really matching the sky right now, but yeah, that's the visual sides of things that can be tweaked later on. So how does this actually work? Well, we have our Waterline with the default settings, which is set to single player, and the way that single player works is actually it grabs the current player controller, player index 0, and gets the pawn and the forward vector and actor location, and sort of gets all of this data and builds upon it to figure out where the character is, so it can spawn the higher quality visual effects to it. So in case any of this changes, like you have a gameplay or something where the player index changes, make sure that you update the functionality here. You could see that this is under Waterline Gen 3, and this is a POV tracker. You can search for POV tracker and you will find the material function here. We can't really show too much of this blueprint because it's part of our product, but essentially this is the part that you'd want to modify. But let's have just a quick look at how this stuff gets assigned player controller. Well, if you go to your map and world details, it's all under your default pawn class, third-person character, and here is our controller, player controller, and you could search for these in the third-person project, and this will give you a bit more details into how this is set up. Now, this is the default Unreal Engine 5, but chances are if you have a game project with a bit more depth, this will look a little bit different. So yeah, for a very basic character interaction, there's very little you need to do. If you're just building something off of the default third-person template, everything is pretty much working from the get-go. So next up, let's see with something a little bit more complex. So next up, we have our advanced locomotion system. So we've created a separate project for this because it comes its own complete package, and to which we have migrated WaterlinePRO 2. Same as the old rule, we've created our own collision channel, and just to test everything, it's working pretty good. So let's just add a quick Waterline volume. Oh, just something noteworthy. Sprinting is working. The climbing system is working. It's pretty great. How was it? E-shape, roll, sprint, walk, ragdoll X. And yeah, so ideally we'd want to be able to do all of these things with Waterline. So to start us off, let's add in our ocean sim, throw it into the scene, add a little bit of depth, and hit play. So straight up, we could see that our water simulation is working fine. What was the crouch? We're doing pretty good. We can ragdoll. So ragdolling right now will turn off our water simulation for some reason. And we have also lost the ability to vault over things. Next up, if we go to our box carrier pawn, let's see, binoculars. We sometimes lose the water simulation as well. So let's address all of these issues. So the advanced locomotion system is a bit more advanced in general and uses a couple of things that more complex character setups might use. So let's just dig right into that. So for starters, let's address our climbing or vaulting system. So the advanced locomotion system uses a custom tracing channel to achieve this. And basically we need to tell Waterline to, well, ignore it. So we just need to open up our Waterline folder, search for volume here. We need to select the sim capture volume, the post-process volume, and the buoyancy volume. Next up, we need to open up collision presets. We may need to expand the, oh no, we don't really need to expand the advanced, and basically change this climbable. So this is like the custom trace channel that ALS uses, and set it to ignore. We also have another thing that we need to search for, and that is the activation box, and do pretty much the same thing. Oh, this one is already set for us. Oh no, actually it isn't. So climbable, set to ignore. Just need to compile it, and let's play our demo again. So now when we run over to this wall, and we have vaulting, and everything is working perfectly. So this is something that you may need to account for if your game or project or whatever uses some custom tracing channels. Just make sure that sometimes other assets that use these may not be aware of them and need to be accounted for. For example, right now we just needed to set this to ignore, because otherwise some of the collision volumes from Waterline, which aren't technically used for collision at all, will collide with the logic of the character that tells it how to find a climbing wall. So this is just something to keep in mind. These are the kind of things to think about when applying Waterline to your project. Generally, they're not too difficult, and it's just something you kind of set up from the very beginning, and you should be all good. So next up, let's fix our water simulation with more complex characters like the binoculars preset and the water box carrying preset as well. So for this one, we're just going to open our asset ALS, our main character blueprint for advanced locomotion system. So we could see that our collision already has generate overlap events enabled, which for the most cases is pretty much enough. But in this case, since our character is a little bit more complex in our setup, what we're going to do is select our character mesh. We're going to select generate overlap events, and we're also going to enable multi-body overlap. Now you may need to enable this in case you have a more complex system with item slots or characters made of multiple parts. So this is also something to keep in mind if you have your own custom character system. So we're going to hit compile, and we're just going to run the demo again. So this is working as expected. Let's switch to barrel, working, binoculars is working, box working. So all of this is pretty much as expected now. And finally, let's just see our ragdoll. So yeah, this is not working too great at the moment, so let's fix that as well. So now let's jump in and finally fix our ragdoll. So for this, we're going to be selecting our ALS animation component. We'll be making some small edits to the blueprint. So first of all, let's get to, we actually don't need the anim main character blueprint, but through it we can navigate to base character blueprint. And once in here, we open up the ragdoll system, ragdoll start and ragdoll end. So first of all, in ragdoll start, we're just going to paste these. So this is if you right click and set tag, we can get actor. So set tags, this is what this is, and we can make array, and as soon as we connect these two, we can start typing in things. And you would see that right now we have our actor tag on right here, and we've also kept a tag that the ALS system uses. So this appears to be something for the camera channel. So at the start of the ragdoll, we are going to set basically actor tag on. At the end, let's do the same thing, copy paste, connect it, and well, we're gonna get rid of our on tag. In fact, we could just right click, remove element pin, and just the original tag that was here. Another thing that we need to do at the ragdoll start is actually change a couple of things here, because Waterline does require collision. So in our capsule component that says no collision, we're going to set collision enabled, Korean physics. Next up, for our mesh, we're gonna set that to pawn. We're gonna hit compile, and let's test it out. So we fall, and now our character makes collision. We rise up, and no more collision. So technically, there might be better places to put these tags in, slightly more advanced, but this is just kind of the headspace that you guys need to be in if it comes to creating custom character classes. Basically, the capsule component or something needs to be needs to have collision to register with Waterline, just so it knows that the object still exists, and your character should remain in the pawn channel, just so it doesn't lose our sort of single player component that Waterline centers around. So let's have another scenario after this one. And finally, let's have a look at metahumans and how we can get them to work with Waterline. So for starters, let's look at metahumans as a player character. So for this purpose, we've downloaded the Metahuman template, and we've migrated Waterline, much like in the previous method. We've just created our own custom Waterline channel. And now we're just going to open the map. And if we press play, we have our very own little Metahuman running around. The only thing that we've really changed from the default setting is we're at current location, because otherwise it always starts at the top of this hill. So let's place our ocean, Waterline. There we go. Add a little bit of depth, and let's hit play and see what happens. So straight from the top, our Metahuman is interacting pretty much the way we'd expect with Waterline. It works perfectly, and we have a ragdoll that breaks again, much like ALS. And with R we enable ragdoll, and with T we jumpstart everything from the beginning, and our animation works correctly. So again, we're gonna have to make some slight changes to the Metahuman blueprint. To find it easier, we're just gonna hit F8 during play and select our Metahuman, press edit in blueprint, and that's just gonna give us this menu. And right now we can stop the play, the simulation, and everything. So what do we need to do? Well, for starters, we have our ragdoll settings here, and we can do set tag actor, set tags perfectly. So whenever we start the ragdoll, gonna make array, and we're gonna give it the actor tag on. So this is pretty good. Let's compile and see what happens. So press ragdoll. Oh dear, everything is still not working properly. Well, what we need to do is just double click the start ragdoll, and it's gonna take us to a different blueprint component. We need to go to the event graph over here, just double click it. And once again, when the ragdolling happens, our capsule component part of our Metahuman says no collision. So in this case, let's see if we can get away with just a query only. So let's compile, press R, and yeah, this is pretty good. Though we could see that our actor is always part of this sort of simulation. So whenever he falls, there's like a little stop. And after he gets up, the actor tag on is still persistent, and he's simulating all the time now. We don't want that. So we're just going to copy these two. And look, we have a nice T, which is our recovery button that switches animation. So we're just going to paste this here. And whenever we press T, we're going to simply get rid of the actor tag on, and everything is going to continue as planned. So let's compile now. And ragdoll, pretty good. And T, we're recovering. And based on velocity again from our pawn, our actor is either within or outside of the simulation. So this is pretty good. But let's take it a little bit further, and what we're going to do, well, let's just grab this delay over here, set it to 1 second, and 1 second after the ragdoll, we're just gonna get this here, and let's copy paste our set array here, set actor tag blank, and do that. So what's gonna happen? Switch to ragdoll. We're gonna set actor tag on. All the ragdoll logic is going to play out, and afterwards we're going to wait for 1 second, and we're going to get rid of our actor tag on. So let's compile now, play, we can ragdoll, our character has fallen, and look, he no longer leaves a little outline spot. Let's recover with T, and he is back. So let's go to a slightly shallower end, and there we go. So looking pretty good. Now we could probably play around with the position of, or rather timing of, when the sort of recovery happens. Just for the record, because this was slightly bugging me, this is the correct order. So when we press T, our actor tag on is temporarily forced on, the animation plays out, a delay of 0.5 seconds, and then we get rid of it. So the way this looks like is fall off, so stops generating waves, starts generating waves, and stops again. So yeah, there you go, just so you know how to do things super on properly. Also, this is Unreal Engine 5.1, so there's this horrible squares that appear. If you want to get rid of this, TSR shading, rejection flickering, set to 0. That's the console command in case you didn't catch it. And yeah, just makes everything a little sharper and better looking. So now let's have a look at adding Waterline to the basically the default Metahuman scene. So once we hit play, yeah, this one.
I am a meta.
So what we're gonna do, let's hide this second character first of all, and select the blueprint. So what we're going to do is set the new the tag, actor tag on, and next up we're just gonna set it to generate overlap events for the body, generate overlap events, and this will also require multi-body overlap. So just as a quick test, let's add in our Waterline Ocean. So let's just do a quick test just to have a look at how big the waves are going to be, because these might be a bit of an overkill for this instance. Let's see what it looks like. Yeah, slightly too much displacement going on there. So let's just flatten things out by just lowering the wind speed of the FFT simulation. So wind speed, set that to 5. Let's just preview what that looks like. So this is pretty good. Once we hit play, is everything looking good? Yes, it is. So now let's start digging into what it takes to make the character interact with it. So to start everything off, let's select our Waterline actor. What we're going to do is set the camera tracker to track actor, and for track actor we're going to select our Metahuman, so blueprint Ada, and this will allow us to basically do the thing where we just start simulating the game without getting any errors, and we can quickly see what and how our water simulation is working. So right now if we press play, yeah, it's not really working at the moment. So let's select our Metahuman, go to body, and make sure that we're generating overlap events and that multi-body overlap is enabled as well. Next up, let's have a look at the collision, and right now the collision preset is basically no collision, so this isn't good for us. We're gonna select custom, and what we're gonna do is collision enabled, so query only. And let's see if that's changed things. So yeah, we can see the little wobbles, and we're basically in business. So right now we're using the default sort of gameplay friendly Waterline settings for the simulation, and they're looking a little bit horrible. So let's see what we can do about these. First of all, we can hide some of these settings and enable shallow water sim. We obviously want that. Now in this case, our range is 8, which is pretty big given our scene. Actually, this character is fairly small, so we could probably get away with a range of something like 4 or maybe even 2. Next up, simulation depth offset. In this case, let's set that to 0 for now. Simulation resolution, we can lower that to something like 256 because we have lowered our simulation range considerably. We don't need that high of a simulation capture to work with this character. Simulation texture resolution, we can actually increase that by a lot, just because we're kind of working on a pre-rendered kind of thing, and performance isn't too important at the moment. So let's see what that gives us. So this is already looking quite a bit better. Let's set the r dot ts for super resolution shading rejection to 0, so we can get rid of the components, and this is looking pretty good. Now the thing to remember is that she's generating waves because she's always part of the water simulation. This is what the actor tag on tag does basically. And if you want to get something a bit more advanced, you will probably need to do a mixture of what we've shown so far, in that certain animation states or certain points of the animation will disable the actor tag on, and other parts will enable it, and so on and so forth. But for the time being, let's see what we could do just to get the maximum amount of quality from the simulation. So after some tweaking, these are sort of the values that we ended up with. For simulation height, we lowered it to 0.5. Range is currently at 2 because, well, this is how big the scene is. And dampening, we didn't really change it. For normal texel size, we kind of kept it the same. Simulation resolution, 256, gave us the best results at this size. And simulation resolution, we bumped that as much as we could. And we slowed down the simulation speed a little bit so the water behaves more realistically. Now there is one last quirk now. In this particular scene, this character is actually quite tiny. What we mean by that is if we put in a cube, which is technically a meter by meter, next to our character, we could see that the cube is quite large. And let's go to unlit view. So yeah, this character is slightly over a meter tall, and yeah, it's not quite ideal for the tiniest of captures. But let's see what we've got so far. So let's play the scene in selected viewport. So we could see that the hand generated waves when it went through the water. And yeah, let's just have a look at this in the simulation viewport just so we can get a better view of things. And yeah, this is looking pretty great, but as we mentioned, this character is a little bit tiny right now. So something cool that we could do is actually just scale it up a little bit, and that should immediately give us slightly better results. So yeah, there you go. When rendering things out, scale is quite important to keep in mind of. We do have quite a few settings to alter it, but there are just some settings that will give you a much better sort of performance at a reasonable sort of scale. So there's really no point to really crunch these numbers. For example, if you feel that this character seems giant in terms of the environment, well, a simple thing that we could do is, simply change the scale of the tiling. Because technically, in a way, scale is relative in a lot of these scenarios. So making everything else also larger will kind of preserve the sort of overall feeling. So for example, in this case, we just doubled our wave tile FFT, and basically our waves are now, ocean waves that are being simulated are now more in context with the scale. And yeah, things are starting to look better and better. Now again, we kind of do have this sort of a Fresnel effect. Can we pause this? Perfect. And now, as per usual, if you haven't seen our other Waterline tutorials, if you don't like something in particular, you could continue to fine-tune it in these settings. So for example, this sort of white Fresnel effect is probably not really appropriate for this scene, so while making it outright black is probably not the greatest idea, but yeah, something like that. Just getting some highlights from the light. And yeah, overall, this is pretty much the sort of things you need to keep in mind when getting Waterline to work with your characters. As you've seen at the beginning of the video, we kind of already comply with the more sort of mainstream, more simpler character setups that you could have. But in case you have something a bit more ambitious or more sort of challenging, more specific to your case, these were the sort of blueprints, tweaks, and settings to keep in mind of that Waterline also uses, and you can use to adapt to pretty much everything you have. So yeah, without further ado, go make awesome things.